Hello and welcome. This is the experimenter, and today we are here with another interesting integral which is there on the screen. You can see it in the highlighted portion. But before I start, I would like to thank my friend for suggesting me this. This might look like a simpler integral, but the answer is pretty amazing. So let's see. And I would strongly suggest you to pause this video right now and just give it a try, because trying out something is always fun. And I'm proceeding with the solution. So before we dive into this, we need to know a bit about this. This problem first appeared in 1944 in the Journal of London Mathematical Society, and the person who first published this was called D.P. Dalzell. And the best part about that is D.P. Dalzell was an engineer by profession, but he has published many mathematical papers, and he was quite reputed as well. So let us just carry on with the solution. The solution is pretty straightforward. As we can see, the numerator part, it has x to the power 4 multiplied with 1 minus x whole to the power 4. So we can just expand 1 minus x whole to the power 4 by binomial theorem and just multiply x to the power 4 with it. And by doing this, I'm just skipping this part. Just give it a try. I'm leaving this as an exercise. So when I'm done with this, if I expand, I get something like this. And just like I've pointed over here, if someone just finds trouble, 1 minus x to the power 4 can be expanded by binomial theorem. We know the formula. You can just check it once. So now the integral is, we are evaluating the integral. Just one thing, I've missed the integral sign in the right hand side. Just give it there. So I is x to the power 7 by 7 minus 4x to the power 6 by 6 plus 5x to the power 5 by 5, which is x to the power 5, minus 4x cubed by 3 plus 4x. And this part, 4 by 1 plus x squared dx, is a standard integral, and that stands for tan inverse of x, or in some other books you might find the word arc of tan x. So now just put the limits and just see what happens. This is the first part, and the second part, tan inverse 1 is pi by 4 and tan inverse 0 is 0. So we have a cluster of fractions, minus 4 into pi by 4, which is simply just pi. But now let's just focus on this cluster of fractions. If we just simplify this, this turns out to be 22 by 7. Does this number seem familiar? Does this number, are you familiar with this number? Yes, of course we have. We have done this several times when we were a kid. When we were a kid, we used to approximate pi as 22 by 7, and that is why I was telling the answer is pretty much amazing. As we can see, the fractional part reduces to 22 by 7, and we are subtracting pi from it. So it looks like our approximation is not quite right. But is it more than, whether we overestimated or underestimated? Let us just find it out. And this is the best part of this integral. Just see, the integral just reduces to 22 by 7 minus pi. I don't know about others, but I have done this several times when I was a kid. I used to calculate the area and the circumference of circle by using 22 by 7, because pi is an irrational number and the digits, it's not possible for us to remember. So we just approximated it by 22 by 7, though there are many approximations right now. There are many accurate approximations of pi, but still let's just focus on this only. So this is the answer of this crazy integral. Now one thing you might just note, yes, this is just, I'm just repeating this. In junior classes we often used to approximate pi as 22 by 7, but this is wrong. One thing you note, you just focus on the white portion on the blackboard. As I have circled the integral, you can see that almost all the powers are even. That means the integral is always positive, because the limit goes from 0 to 1. So if the integrand is positive, then the I, or the value of this integration, is always positive. So the value of I which we got should be greater than 0. So it is quite clear by now that 22 by 7 minus pi is greater than 0. That means that we have overestimated the value of pi as 22 by 7. And that's what we have proved over here. Thank you.